We spent significant time introducing joins and the inner join type. The benefit of doing this extensive introduction was that now you can quickly understand and learn other types of SQL joins. The Venn diagram you see here allows you to visualize how a left join works. Its output allows us to see all records from the table on the left side of the join, including all matching rows of the two tables. That's why, compared to the inner join, the result set, colored in red, includes the rest of the area of the left table. In SQL terms, this translates in retrieving all matching values of the two tables, plus all values from the left table that match no values from the right table. To clarify this concept, let's see an application. First, let's remove the duplicates from the two tables. This would allow us to explain the types of joins we will introduce in the next few lessons better. Duplicate values inflate our output with repeating records and do not contribute to the results we obtain meaningfully. That is why we decided to complete this section about joins without them. Practicing with duplicates will be left as part of the exercises in this section, so don't worry. You will deal with them while proceeding with the course. All right. Technically, after deleting the rows in which we see the respective employee and department numbers, MySQL will delete all initial records and all their duplicates. So, to proceed, we must add back the initial records. Please, don't forget to do that. Aha! Okay, everything looks good now. So, do you know what else we can do? We can load the same code we used in the previous exercise. The join syntax will be subject to a slight change though. Instead of relating the two tables through the keyword join or inner join, we must type left join. Okay, that's all that needs to be modified in the code. Let's see what will happen when we execute this query. It returned 26 rows. 6 rows more than the 20 rows we obtained in the example about inner joins. Which are these 6 rows that make the difference? Let's check this out. To start our analysis, please refer to the Venn diagram. These 6 records represent the area filled with blue. This is the part of the left set where no values match with the right table. Technically speaking, luckily, all 6 records of interest are in the top part of the output. First, all 4 records that appear in the manager's table but are not seen in the department's table have been retrieved. They refer to employees with numbers 999, 904, 5, 6, and 7. Why are these 4 rows retrieved? Because they were registered in the table on the left, but not in the table on the right. There are no department number values that could match these records with the table on the right. Hence, they are an example of non-matching values from the left table. Great! There are 2 more records we must discuss. The ones of Department 2 from the left table, Department Manager Duplicate. They appear in the left join output. If you remember, there are no such records in the department's duplicate table, right? There, we had information for departments 1, 3, 4, 5, and so on, until 11, and nothing about Department 2. The 2 records appear in the final left join list, but there are no corresponding values for the department name field that can come from the table on the right. Perfect! Basically, this is proof that, differently from what we saw for inner joins, when working with left joins, the order in which you join tables matters. Having the manager's table, M, or the department's table, D, on the left can change results completely. In the next video, we will provide an example of what happens when we switch the order of the 2 tables. Thank you for watching. In this video, we would like to emphasize that, in certain occasions, the order in which you join tables in SQL matters. Let's invert the order of the tables. We will place the department's table on the left and the department manager table on the right. rerun, and a different output. This was due to our swapping the direction of the two tables. So now we will have all matching values from the two tables plus the department numbers from the department's table that match no value from the department manager duplicate table. Therefore, we can expect to see records for departments 1, 10, and 11, right? Okay, but why don't we see any of them? The answer lies in the way we've chosen the first selection in this query. After we inverted the order of the tables and executed the query, the output changed, but that is not so obvious. To reorganize it properly, please retrieve the department number data from the department's duplicate table, not from the department manager duplicate table. The correct way to do that is to retrieve the first selection from the first table you have set in the join syntax. Good. Now, let's execute the query and check its output. Great! The picture is the opposite of the one the analysis just conducted, referring to the Venn diagram. Imagine that. With this query, we swap the places of the two tables. That's why, in the results section, we have only one null department number value, and we have data about Department 1 that has no information about an employee number. The latter is a consequence of the fact that we have no data about Department number 1 in the manager table. All right, and because the departments table contains no information about the second department, there will be no record about it in the result set either. Finally, as you scroll down, you'll see information about all departments from 3 to 9 with corresponding employee numbers and department names. At the end, as you probably expected, departments 10 and 11 are quoted, with no information in the remaining two fields. This is all fantastic. Now, let's examine a few syntactical peculiarities. We studied inner joins in the previous lessons. Why are they called that? Because the values in the output are common to the two tables, and the result set is in the inner part of the Venn diagram. It is the area where both circles overlap. So, outer joins must exist too. The left join falls in this category, since in the output obtained, you have data from the outer part of the Venn diagram too. My point here is, in this case, you could also use the keywords left outer join and you will extract an identical result. Therefore, if we rerun the query, adding the keyword outer in the code, the outcome will not differ from the one we obtained earlier. True? Absolutely. We obtained an identical result. Just remember that left join and left outer join are two interchangeable phrases. From a professional perspective, there is no reason for typing the keyword outer here, because if you are using a left join, it will always be an outer type of join. This is like omitting the word inner from inner join, if you remember. Therefore, as long as it is clear what type of join will be applied, professionals prefer shorter phrases. Cool. There's one final interesting detail I'd like to add. Left joins can deliver a list with all records from the left table that do not match any rows from the right table. Put differently, the idea is to obtain all records that appear only in the left outer blue part of the Venn diagram in this picture. Which are these records in our case? Looking at the output obtained with the first left join, these are the top 6 rows of the data list. You see? They have null values in the department name field. And how do we get to these rows programmatically? The trick is to include a where clause, whose condition will be all department name values to be null. So, you must type where department name is null. Through a left join, we will retrieve this bit of the table, whose column information comes from the right table and is null. Makes sense when you think of it, doesn't it? Let's execute the query and check if we will obtain a 6-row result. Bingo! Yes. Can't be better. Now, roll up your sleeves and have a go at the exercises attached to this lesson. See you in the next video.